Evening, students. I welcome you all for today's composite materials class. Today I am going to discuss about stir casting process and squeeze casting process to produce the metal matrix composites. Okay. So already mentioned, today I am going to discuss about the stir casting process. So in the previous classes, I discussed about the different properties related to the metal matrix composite, their advantages and disadvantages. Okay, so this today I am going to discuss about the stir casting process. Okay, so the stir casting process is like one of the like very economical process to produce the metal matrix composites. Okay, this techniques mainly involves the incorporation of reinforcement particles, like most probably we'll use the ceramic particles. Okay, these ceramic particles will incorporate into the molten metal matrix. So and after that when after, while you are adding these particles, ceramic particles to the molten metal matrix, after that this particular process is followed by the stirring of this particular mixture, that reinforcement particles in the metal matrix. That's why this process is known as the stir casting process. So stir casting, already mentioned that, is very economical process to produce the metal matrix composites. In this stir casting process, okay, we are going to add the reinforcement particles. Most probably use the different ceramics like titanium carbide, silicon carbide, or aluminum oxide, like other different ceramic particles we are going to use. These particles will like use to uh, added to the metal matrix. Okay, we'll use some different types of metals as the matrix. You can use the aluminum, magnesium, copper, or different metals you can use as the matrix material. Okay, these are like now I'm going to explain about the different steps in the stir casting process. So first step is the preparation of the matrix material. So depending upon the requirement, we have to choose the matrix material. That matrix material may be like aluminum, magnesium, and different types of like alloys of aluminum and magnesium, or other different metals also you can choose based on their like their mechanical properties and their strength properties and other like lightweight and other different criterias. Based on that, you will select the appropriate matrix material. The second step is the addition of the reinforcement. So already mentioned that based on the your requirement, you have to choose the appropriate reinforcement material, like can use silicon carbide, or like also like aluminum oxide Al2O3, or graphite particles you can use, or titanium carbide particles you can use, or boron carbide particles you can use. So such type of particles are can use. So in before adding these particles into the molten material, these reinforcement particles will be preheated so that the moisture, to remove the moisture and to avoid the formation of the oxides during the process. So that's why whatever the reinforcement you are choosing, that reinforcement particles will be preheated to avoid the formation of the oxides. So this, due to this, like it will improve the wettability of the reinforcement whenever you are adding that to the molten material. That's why we are going to preheat that particular like reinforcement. So next step is the stirring process. The start step is once the matrix is fully melted. After that, we are adding the reinforcement particles. Okay, for example, like we are choosing the aluminum matrix as the matrix material, aluminum material, the matrix material. Then I will make to I will place the like entire this aluminum material in appropriate quantity in that no, crucible, and after that this crucible will place in the like furnace and will maintain the temperature such a way that the aluminum will reaches to the melting point. So we'll make it like the temperature will set as above the 660 degrees centigrade such a way that once the entire molten material is reaches to the its molten form, then we'll add the reinforcement material like whatever we already mentioned. We can add aluminum oxide or graphite particles or different other particles we can add. Once we are adding these particles, then we have to thoroughly mix this like entire mixture of the reinforcement into the metal matrix. That's why we will perform the stirring action. So there will be a stirrer will be there in the stir casting machine. So we'll make to perform the stirring action. Due to that, this stirring action is very important in this particular stir casting process. Mainly it helps in breaking the agglomerates of the reinforcement particles and ensure a uniform distribution throughout the molten matrix. Okay, so randomly we are placing the reinforcement particles by this stirring action. It makes that whatever the agglomerates that form during the process, it will break those reinforcement particle and ensures that these particles may distributed thoroughly throughout the molten matrix. So that is the main purpose. So why we are going to perform the stirring action is like that entire reinforcement materials should properly mix in the metal matrix. For that we are going to perform the stirring. Okay, so after that once after maintaining sufficient holding of that particular reinforcement and in the molten metal, this one after performing stirring action, this composite whatever the melt, okay, you prepared, that composite melt is poured into the mold. So already based on the requirement what type of product you want to manufacture, based on that already you may fabricated the mold. So in that mold we are going to pour the molten material. So that is the to obtain the desired shape. So that thing, that is the fourth step. And the fifth one is already normal, like once you pour the molten material into the molten composite melt into the mold, after that we solidify that composite mixture. So during that the composite this particular composite mixture is allowed to cool, and it will solidify in the mold. The cooling rate can be significantly will influence the microstructure and properties of the composite. Okay, and after that the last step is the post processing. Like once you the solidification and process is completed, after that based on the requirement we can perform some different post processing operations we may apply over the fabricated composite metal matrix. Like we can perform to increase its other properties. Okay, sometimes the metal hardness may get increased to make decrease its hardness or to improve its strength properties. Further other things we may perform some heat treatment operations, or sometimes some minor machining process you have to perform. Such type of post processing operations we can perform in this particular post processing of the metal matrix. Okay, so this is the layout. You can observe that especially how the this particular steel casting setup is going to looks like. Okay, you can see that this is the setup related to the steel casting setup. Okay, is especially consists of like a one furnace. This is the entire furnace you can see. Okay, the this furnace okay have the different for heating purposes, or again to operate that no, stirrer. This is the stirrer. Okay, you can see that This one has the impeller blade at the lower end, and this is connected. It's entire stirrer, because we have to rotate the stirrer continuously. For that, that stirrer is connected to the motor to perform the rotary action of the particular stirrer. And at one end, that stirrer it have the impeller blade. This is the stirrer rod. Okay, and to control that rotation of this particular stirrer, we can operate there is a separate control panel will be there, where like there will be some based on the requirement configuration of the equipment. We may have some different 3 or 4 levels of speeds. We can vary the like this particular stirrer speed. Okay, and like that once we already mentioned that in this particular furnace, this is the entire furnace. This we are placing the crucible will place the like aluminum billets, and will make the switch on the furnace, and due to that no, heating effect, it will makes the like whatever the metal we are placing, this will melt the material, and after that will like insert or place the like pour the like mixture of reinforcement inside in the crucible, and after that so we'll this is the like how we can going to feed the like reinforcement. You can see this is the reinforcement feeder, where we are feeding the reinforcement like this. It will come and at this particular level it will added over the molten material, and after that we'll can see this is the rotary like some clockwise rotation is going to happen when like whenever like you want to make the like stirrer to perform rotary motion, then we are going to switch on this particular motor, and we can set the appropriate such a way that the stirrer will perform rotary movement, and these impeller belts also get rotated, and they will mix the molten mixture with whatever the like reinforcement particles are there. They will mix thoroughly, and after once like after thorough mixing of this particular composite mixture is developed, after that at the bottom there will be opening is there. We will open that bottom pouring opening. This one is the bottom pouring opening. So then at the below that we'll place the mold. So whenever you remove this particular opening, this molten material of composite mixture will pour into the mold, and after that we'll solidify for certain time, and after that we'll remove the component from the mold. So that is how that stir casting setup is going to work. Okay, and what are the advantages of stir casting process? Mainly, I already mentioned that it is a very like cost effective process. Mainly, it is inexpensive. The stir casting process is very inexpensive, very low cost process when compared to other manufacturing like powder metallurgy, other different techniques. The setup required, this one is not that much costlier, and versatile. So this based on the what type of furnace you are using and what are the temperature ranges that are we can operate. Based on that we can select the different varieties of matrix materials I can choose, and that those materials I can mix like different reinforcement combinations also can choose based on the requirement. So that is the versatility here. So based on the like what type of like furnace you are in, based on that you can choose the based on the temperature ranges you can select the appropriate matrix material, and also this particular stir casting process easily having that scalability options, even it is suited for large production volumes also. And the one more very advantage of this particular stir casting is the like operation of this particular setup is very easy, the simple process. So that is the one of the advantage related to the stir casting process. And what are the challenges and the limitations in this particular stir casting process is mainly like reinforcement distribution. So achieving like uniform distribution of reinforcement particles can be challenging. So we are through the powder feeder we are supplying the reinforcement particle powders like silicon carbide or boron carbide or different particles we are adding. So while even you are using the appropriate speeds, all these things, like distribution of this uniform distribution of particles in the matrix is always a challenging in the stir casting process. Okay. And porosity, the process can also introduce some porosity into the final composite, which will affect the mechanical properties. Whenever like any casting or any product has this porosity, okay, then it will definitely will affect the mechanical properties. So we have to like continuously maintain the appropriate temperature and stirring actions. Okay. And one other disadvantage, or can say limitation, is the interfacial bonding. The quality of bonding between the matrix and the reinforcement is somewhat not that much sometimes the reinforcement particles may not properly bonded towards the matrix, especially in the like if you are not maintaining appropriate no, wettability conditions, all these things, then it may not the reinforcement particles may not properly bonded with the matrix material. That is the one of the limitation of this particular metal matrix composites. Okay. And mainly these coming to the applications of stir casting. Okay. The stir casting process can be used for in it can produce different products related to the different industries, like in automotive mainly to produce very lightweight and high strength components like pistons, cylinder liners and brake rotors. These you can produce by means of the stir casting process. And aerospace, like structural components where some high strength to weight ratio is required, such components also you can uh, produce by using the steel casting process. And also like different uh, elements, or can say products related to defense like armor materials. Okay, they also can produce by using the steel casting process. And also can use the like sports equipment related to the different metal matrix composites, like those also can produce by using the like this steel casting process. You can use like golf clubs and bicycle frame. These also can produce by using the steel casting process. Okay. The next process is the squeeze casting process. So this squeeze casting process is like somewhat you can say that some like extension related to the squeeze casting process. The same setup, some can add some local squeeze squeeze casting setup we can add to the stir casting. In stir casting like process, we are not no, when you are pouring the molten material into the die, you are not uh, pressurizing the molten material into the die. But in the case of squeeze casting process, we have a separate setup. Okay, with certain force will pour the molten material into the like mold. In the especially in the case of squeeze casting process, that is the only you can say some added portion you can observe in the squeeze casting process. Mainly in this particular thing, I'm going to discuss about the what are the different steps in the squeeze casting process. Mainly first you have to prepare the die. Okay. Whatever the like requirements. Okay. Dimensions and what type of product we are going to manufacture. Based on that, we can prepare the die, and most probably you can use the high strength steel as the like die material. And like so most of the cases you can even preheat the die also. Okay. And after that, melting the metal matrix material. So like same like steel casting with the here also will melt the uh, we'll place the what is entire the billets of metals in the crucible. And after that we'll maintain that, we'll increase the temperatures and will maintain the temperatures. Due to that, the molten material will be melted in the furnace. Okay. And after that, we'll add the reinforcement. Okay. You may choose silicon carbide, or you may choose different carbon fibers or aluminum fibers, or you can choose boron carbide or titanium carbide. Different particles you may choose, and these reinforcement can be mixed into the molten metal before pouring can be done. Okay, that while even after adding this reinforcement also, we can like stir casting. There also that particular setup, you can stir the reinforcement in the matrix, and you can see that proper distribution of reinforcement should be done by this stirring action. Okay, and after that we'll pour the molten material. So the molten material here will pour into the uh, die. Okay, preheated die cavity. Already mentioned that to maintain that wettability, we are preheating the die. So in that we are pouring the molten mixture of composite mixture. So, and after that immediate pouring of the molten material, we are going to apply the pressure. Okay, immediately after pouring the molten like mixture of composite, then we are applying the pressure. Okay, by means of hydraulic press or mechanical punch. Okay, so this particular setup will have designed or in such a way that it will have the pressure application mechanism, where we can apply the pressure in the range of 50 megapascal to 150 megapascal, or depending upon the requirement. Some equipments may fuse casting setup, even they have the higher pressure setups also will be there. So due to this application of pressure during the solidification process, which helps in forcing the molten metal into the like very intricate or complicated die features, also the molten metal will be enforced into that cavities. So and this high pressure application improves the metal flow rate into the die cavity, and also eliminate the that's porosity. We discussed that in stir casting, because there in stir casting process, without the application of the pressure, it may develop some porosity. So such porosity is also gas porosity. These things also we can eliminate if you are using this application of high pressure immediately after the reinforcement. Okay, the only the additional setup that is there in this particular speed casting is the they'll have the special pressure application mechanism. Yeah, once you are pouring the mixture of composite into the this particular die, immediately the high pressure is applied uh, over this particular molten material, such a way that molten material with high force, it will flow into the intricate die features, and also it will improve the metal flow, and this makes to avoid the formation of the gas porosity. That's why we are applying the pressure here. Okay, and next one is already the same like that steel casting. Here once you perform the entire the pressure application, under the pressure applied this one, the metal will be solidified within the die. Okay, will the pressure is maintained until the entire component solidifies. Okay, we'll apply the pressure over that particular mixture of material till it solidifies. Ensure that proper amount of densification has to be done to avoid that defect free structures should not be formed. For that will maintain the pressure till the entire component solidifies. Okay, right. So after that solidification, then we have to remove the product, that is ejection and post processing. Once the material is solidified, the component that is whatever the composite component fabricated or produced, that is ejected. That is ejected means removed from the die. The finished product is which will have the fine grained microstructure. If it requires, we can perform some different machining operations we can perform to improve its surface finish, and to remove burrs or anything that develop during the uh, process of speed casting, that we can remove by means of machining, or to improve its properties, we can perform the different heat treatment processes. Okay, This is the diagram related to the squeeze casting process. Okay, you can see here like the first, okay, we are we are preheating the die, and after that we are pouring the molten mixture of composite mixture into the die. Okay, and after that we'll make the punch to move towards the molten material, and due to that high application of punch force, that the punch will forces the molten material into the die cavity. Okay, until its solidification of the material will maintain the high amount of pressure over the or force over the particular molten material. Once the material is solidified in the third step, the punch will be moved upside, and after that by using the ejector pins will remove the casted product. Okay, that is the how the process will uh, the processing steps related to the squeeze casting process. Okay, like what are the advantages of the squeeze casting process is like mainly it improves the when compared to the steel casting, the mechanical properties are improved, and also we can produce the near net shape products. So most probably with like with higher greater tight tolerances you can produce the products. And also when compared to the steel casting, there will be can gas porosity or shrinkage defects can be reduced. And also same like steel casting, here also we'll have the versatility related thing, mainly based on the temperature ranges that you are concerned related to the your setup. You can choose the appropriate matrix and reinforcement material. Sorry. And when compared to the steel casting, the surface finish will be far better when compared to the steel casted component. And limitations are when compared to the steel casting, the cost of this squeeze casting is very high because it is having the additional setup related to the hydraulic press thing will be added to this particular steel casting setup. That's why the cost of equipment is very high. And also there is a complexity in reinforcement distribution, like achieving like uniform distribution of reinforcement particles can be challenging even in the squeeze casting process also, especially in components where the shape of the your is somewhat no, intricate geometries are there, or difficult no, complicated geometries are there. Then in such cases the distribution of reinforcement particles in the matrix material very challenging. Another one is the process control, like the process there are like different process parameter we have to properly control. Like we have to maintain appropriate temperatures, or we have to maintain appropriate pressures and also cooling rate. These should be controlled very properly to ensure the desired properties. We are not able to control these temperature, pressure and cooling rates properly, then it may cause to some shrinkage cavities or other different porosity defects may develop in the casted product. So to avoid that, we have to properly control the temperature and pressure and cooling rate during the squeeze casting process. Okay. Coming to the applications, mainly we can same like steel casting, here also we can develop the different products related to metal matrix, engine blocks, pistons, suspension parts and brake components related to automobile industry. And also you can even manufacture aerospace industry related items, and also you can manufacture defense related items also you can manufacture. And also different industrial equipments like high wear resistance and durability related components we can manufacture, like gears, rollers and pumps. Like this we can manufacture different no, components. So that's how this squeeze casting process is going to perform. So That's it, students. Today I discussed about the steel casting and squeeze casting processes. Hope I think you understand about this particular processes. Okay, thank you.